In this video, we will be solving a project crashing problem. This is a very simple project network, so it'll be easy to follow along. I've drawn out the network. We have crashing available for some activities, but not all. We know the cost per day to crash each activity. We know the maximum amount of benefit we will get for every day of crashing. And so, for example, some activities like H, it costs $2,000 a day. The benefit for crashing is only $1,500 a day. So we would never want to crash activity H. It's too expensive. So there are multiple ways that one can do these problems. I like to start by making a list of all of the paths through the network. Again, relatively simple network. So the first path goes A to B to E to H, and I'm just going to make a list of each of these paths here, A to B to E to H, and that takes 3, 4, 5, 6, 7, 8, 9, 10 days. The next path, working my way down, is A to C to E to H, and that takes 3, 6, 9, 12 days. And then across the middle here, we have A to C to F to H. And that takes 3, 6, 10, 13 days. And then our last path across the bottom goes A, D, G, H. And that takes 3, 4, 5, 6, 7, 8 days. Of these, obviously, the longest one is A, C, F, H, 13 days. So I just like to underline that to help me remember which is the critical activity, or which are the critical activities, what's the critical path. So it doesn't make sense to crash anything unless it is A or C or F or H, because if I crash anything else, it will not get the project done faster. Okay, so A would cost $1,100, C would cost $700, F would cost $500, H, not an option. So of those, A, C, F, and H, A, C, F, F is the cheapest. So I'm going to write an F here, so I can keep track of this will be the new time that everything takes once I've crashed F. So F goes down to 3 days. So anything that has an F in it is now 1 day faster. So A, B, E, H, that path you can see has not changed. It's still 10 days. A to C to E to H, again, not affected by the reduction in F, but A to C to F to H, that's now 12 days. And then A, D, G, H, not affected by crashing F. So we can see that the two longest paths are now the original path, ACFH, and then ACEH is also critical. So now we have two critical paths. And then, by the way, I also need to keep track of the fact that I originally could crash F twice. I've done it once, so I only have one possible day of crashing left. Okay, so now as I look at it, I need to crash activities on both paths. Again, H is off the table. I could crash A, that would be $1,100. I could crash C because it's on both paths. That would cost $700. Or I could crash E on this one and F on that one, and that would cost me $900. I'm trying to do this in the order of cheapest to most expensive. So out of those options I just listed, C is the cheapest. So C will go from 3 days down to 2 days. So this top path, A, C, A, B, E, H, not affected, stays at 10 days. A to C to E to H is now 1 day faster at 11 days. Path down the middle, A to C to F to H, is also 11 days. The bottom path, A, D, G, H, is not affected, stays at 8 days. So now I still have the same two paths that are critical at 11 days. Now C could only be crashed once, so that is no longer an option. Okay, so looking at those two paths, A to C, E, H, A, C, F, H, what are the options? I could crash A because it's on both paths for $1,100, or I could crash E and I could crash F. E is 400, F is 500, so that's cheaper. So crashing E and F, E will be down to 2 days, F will be down to 2 days. So what will happen, this path, again, not affected, this path down to 10, this path down to 10, this path, oh, pardon me, I knew I was gonna do that. So the first path was affected because E is on that path. So it's going from 10 days down to 9 days. So my critical path is not affected, and I could only crash F twice, and now I have crashed it twice, so F is no longer an option. E could be crashed one more time, but crashing E by itself does me no good because it would speed up this path, which would go from 10 down to 9, but this path would still be 10 days, so the project would still take 10 days to complete. So crashing E by itself does me no good. I'd be spending money and getting no benefit. So of the things available, the one remaining is A, and A is on every path. So every path will be sped up. So this 9 goes to 8, this is 9, this is 9, this is 7. And so our critical path remains unchanged. And now we have done all of the crashing that it makes economic sense to do. So now let's see how much additional benefit we have gained from doing the crashing as we have laid it out here. So let's look at the costs that we have incurred from this. Crashing F cost us $500. Crashing C cost us $700. Crashing E and F together would be $900. And then crashing A was $1,100. So that's $2,000 total cost here, be $3,200. So how much benefit do we get from this? Well, we went from originally taking 13 days to do the project. We're down to 9 days. So we have gained 4 days. So 4 days at a benefit of $1,500. We will gain an additional $6,000 from doing it. So the net benefit is just the difference of those two. So we have 6,000 minus 3,200 gives us $2,000 of additional benefit from having done this. So that is how we do project crashing. We started off with the original drawing. We made a list of all of the possible paths through the network. We figured out how long each one would be. We found the critical path. We looked at the activities that can be crashed. We crashed the one that was cheapest. And then we looked to see if the critical path had been affected, so we could decide how to repeat, which activities to consider crashing for the next iteration. We kept going until there was no crashing possible that made economic sense. And then we added up the costs of the crashing activities we did. We found the amount of benefit we would get from the crashing we did, and found the net benefit from those crashing decisions. I hope this has been helpful.